This is a perfect example of why I avoid Tesla Superchargers, because of situations like this. So we're going to see if this will actually help solve the problem. First thing I'm going to do is plug this in. Then I'm going to see if this is going to reach, and it's not. It's just in a low signal to the proximity pilot to disconnect it, to shut the charging down. It didn't do it. If you're using something like this, you have to be fully aware that if you disconnect this and pull this out while it's charging, you could create an electrical arc, which can be catastrophic. You hear it locks in. And so you can't, once you put it in, you can't pull this out without. Hello everyone, welcome back to my channel. Hope you're having a great day today. Well, in today's video, we're going to talk about this extension cable that I tested in my last video. I actually just used, I didn't really go through the full test, and I got a lot of comments in my comment section. And in the meantime, I have been running tests, been doing a lot of research on this this connector. And this connector was sent to me by Hansshow. And there were a lot of commenters in the comment section saying this thing is unsafe and it's dangerous and all this other stuff. And there's another company that's coming out with a safer cable. Well, we're going to look into all of that. Of course, I conducted some extensive research. I even had people say this thing wasn't UL certified, which that is true and also not true at the same time. But we're going to go over all of that. I'm going to break everything down, and we're actually going to go out to a Tesla Supercharger. I'm going to test this thing out. And I'm also going to test the temperature sensors to see if it cuts off when it hits its temperature limit, and a few other things. But let me go ahead and show you the cable. And I'm going to kind of explain how these things work to you. And, you know, just before we get started, I have a couple of different connectors here. And this is the electron connector for the NACS. Of course, it has the NACS side on it and the CCS. And, of course, it has this. And I also have the Tesla approved one. And I also have A to Z. And I believe this is a Typhoon. I have this connector here. And I've used all these connectors. And this one is the one from Hansshow, which is actually manufactured by the War Energy Company, but this is sold on the Hansshow site. And we're going to go over this more in detail. And this is what we're going to be testing today also to see if it's safe. And a part of that, I'm going to be doing my heat testing. I have my flare right here, my infrared camera. And I did use this briefly when we initially was on our road trip just to test to see if this thing worked. And so that's what we're going to be doing today. But before, I just want to break this thing down, but I want to show you some of the things with this cable. Of course, this has the CCS side on it. And if you look in here, it has a little weather ring. And of course, these are the DC pins. And these are the signal pins up here. And of course, this should disconnect it, the DC power when you hit this button. And then this is the NACS end of this. And of course, it has this disconnect, this locking mechanism right here. But there's some questions I have with this portion right here. As far as certification, this is UL certified. And I believe it's the UL certified under UL 2263. But as far as I cannot find the certification under UL 2252. And although the company say there is a listing, I cannot find it in the UL website. And just to go over some of the other specifications of this cable is 5 feet long and it weighs approximately 15 pounds. And as far as the build, then you can come up here. I'm going to show you right here. This is the UL number on this, and this is what I use to look this up and find out the company's information. And this is an EVE cable, and it has 2x2, two alt gauge wires, and 2 alt. What that means is that that's expressed as a 0. So anytime a cable is bigger than 1 gauge, it goes to 0, because the smaller the number, the bigger the wire. And so in this case, it has 2 alt cables, and those are for the DC pins. And it also has a 1 gauge wire here, and more than likely that's for the ground. And it also has 6 18 gauge wires, which are for the signals. And I'm going to show you on this cable, and this is a Tesla connector here. And on here you have two DC pins. One's a DC positive and one's DC negative. And this right here is a ground wire. This thicker one sticking out. This side here, that pin to the right hand side, that is a proximity pilot. And the pin on this side is the control pilot. Now, what the proximity pilot does, this is the one that sends a signal whether or not to disconnect this cable. And so with these adapters, a lot of sweat beads around here. And I'm gonna use this for example. So when you depress this, it should engage the, send some voltage to the proximity pilot to let the charging station know to stop charging. And so basically what it does is that the normal signal is 2.7 volts. And then once you hit this, or either this right here, it has a micro switch in it that connects to the proximity pilot that sends a new voltage signal. In this case, once you depress it, it'll send a 0.5 volt signal to the proximity pilot, which will let the charger know to disconnect. Within milliseconds, it cuts current to the charger. And so that's how this works. And so again, with this, you plug your NACS connector into this. And so you hit this to pull it out, it disconnects. Or if you hit this, it disconnects. Now, what happens if it doesn't? So in a case like this, if this is not connected to the proximity pilot and you disconnect, it can create what's called arcing. The Tesla Supercharger can put out 500 amps, and this cable is rated for 250 amps. And so if there is no proximity pilot disconnect here, if you pull your NACS connector out, it can create arcing between these two things, which means electrical current can jump between here and here. And it's almost like an arc weld. And at that amount of voltage, that would just melt metal like instantly. It can cause fires. It can just jump, and it can be pretty catastrophic. So it can be pretty bad. But and so that's what we're gonna test for. So we go out there, we're gonna click this. If this thing doesn't shut down, then you know it cannot be certified under UL 2252. And this would not be a safe procedure to do. And if that's the case, they need to put some type of warning or something on here. But we'll see. We're going to test it out. And also, if you haven't already, go ahead and hit that like and subscribe button. If you really like the content, and if you watch more than one of my videos, go ahead and hit that subscribe button also. And hit that notification bell. So the next thing we're going to do, we're going to head out to the Tesla Supercharger station. Okay, so I just plugged the Tesla Supercharger into the navigation. And right here it shows preparing battery for fast charging. And so when we get there, it should be at 14% state of charge. It's about 14 miles away. And I'll see you all back when I get there. We're coming up to the Tesla Superchargers. Man, good, it's empty. Oh, there's another Rivian over here. And so I'm just gonna show you, oh no, it's not empty. There are a couple of Teslas there. Matter of fact, almost all the stalls are full. And we have a Rivian that's taking up 2 spots. I'm gonna try to squeeze into here. You know what, there's a one on the end here. I'm gonna try to use this one. And we'll connect the cable up to this one. This is a perfect example of why this cable is needed, because that Rivian is really taking up 3 different stalls. There's a stall on the end, there's a stall right there, and a stall right there. So it's taking up 3. It probably should have pulled into the other stall, but it didn't. So now I'm gonna try to squeeze into this one. This is a horrible supercharger station. Okay, so this might be one of the worst case scenarios. So I'm gonna go ahead and get out. I'm gonna try to hook this cable up, and we'll see how we're gonna be able to test this thing. If I can even get out. Who set this up? This is horrible. Look at this tree right here, can barely get up. So I'm gonna go ahead and hook this up. This is a perfect example of why I avoid Tesla Superchargers, because of situations like this. So we're gonna see if this will actually help solve the problem. Again, this is rated for 250 amps. I'm going to get my heat gun out. So the first thing I'm doing is plug this in. Like so. Then I'm going to see if this is going to reach. And it's not. I'm gonna have to back up. So I'm gonna go ahead and plug this in. I guess the good thing is that this is not on the ground. So, and let's see, it's charging. And I'm gonna get in the vehicle and see how many volts I'm pulling. And right now I'm pulling 366 amps, which is beyond the max in the vehicle. It's current available is 500 amps. So I'm pulling above what this is designated for. But as you can see, it's starting to slowly drop. I'm down at 291, so this might be okay now. 281, 279. And so that might actually be okay, but we're gonna see. So right now it's pulling 114 kilowatts. We're gonna run a couple tests. So I'm gonna go out there and I'm gonna hit it with my heat gun and see what the temperature is. And I'm also going to test this disconnect also without getting electrocuted. I'm gonna test both of them and see if they're in compliance. And it should shut the charging down. So I'm gonna test the temperature on this. So right now this cable is showing 98 degrees Fahrenheit. So it's not even warm to the touch. And the Tesla cable is showing 111 degrees Fahrenheit. And so now I'm going to test the disconnect. So the temperature is what that specs. So when I push this, it should shut off charging. And it did. So it shut as soon as I hit this button, it shut the charging down. And so I know the proximity disconnect works for this part of the handle right here. So that part's safe. There we go. Okay. Now I'm gonna plug back in. So I disconnected and plug back in and it's charging again. And now I'm gonna test this right here to see if there's a proximity pilot disconnect. No, the vehicle's still charging. So this is something they definitely need to correct on this. So yes, this does lock in, but when I push this, it should send a low signal to the proximity pilot to disconnect it, to shut the charging down. They didn't do it. So this is just a mechanical lock, but with no low voltage wire connection to it. If you're using something like this, you have to be fully aware that if you disconnect this and pull this out while it's charging, you could create an electrical arc, which can be catastrophic at the amount of volts or amps that it's pulling. So that's something to keep in mind. Of course, when you look at the instructions for any of these chargers, that's including the Tesla charger, the Electron, the A to Z, all the instructions say before you disconnect to shut the charging session down in the app or either in the vehicle. So even if you go to Tesla's website to see how to use how to charge a non-Tesla, the Tesla Supercharger, when it goes to the disconnect procedures, it tells you to shut it down at the app or either in the vehicle. So to end the charging session first before you disconnect. Now that's the first level of safety. The second level of safety is the proximity disconnect, which this does have right here, but it doesn't have it right here, which would make this very unsafe if you try to disconnect it. It could create an arc, not saying it will. And I'm going to show you those proximity pins and the control pilot pin. They're a lot shorter than the DC pins, but still, so when you disconnect it, those will be disengaged first. But I'm not going to try it. I'm not going to test that out to see, because even when you disconnect it, those DC pins are exposed, and this could send an arc from one to the other. And so it's just not worth the test. So my advice to the company is that this needs to be connected to the proximity pilot for a disconnect, because this is not safe. If anyone can just walk up here not knowing and just disconnect it. So And that's usually what happens. So if you know what you're getting into, like me, I know not to do it. And so I'm okay with using this extension cable because it can either boil down to either charging or not charging. And it does have its use cases, which we'll talk about later. But as you can see, it's still charging. And the ambient temperature around these parts it's over 90 degrees. And some additional things about this cable, it does have temperature sensors in it. And so once it hits around 85 degrees Celsius, it'll throttle the charging, maybe even around 75 degrees Celsius. And when it hits around 85 degrees Celsius, it's going to shut the charging session down totally. And so as far as this cable, as far as as far as heat and things like that, the cable is safe. The cable's UL certified. It's not going to melt. So this cable part is safe. The connector at the charge port is safe. It does have the proximity pin. This section is not in compliance with UL 2252. So if you get this, just be fully aware of the risk you're taking. But this thing definitely came in handy. And so we're gonna let this keep running. I'm just keep doing a temperature test and just let me check again just to see. And right now I got a notification that says charging speed, reduced speed limited by charging station. So more than likely it came from the cable throttling the amount of power that's coming through here, because this cable again is only rated for 250 amps. And so just another thing to be aware of, if you're using this, the best practice is come in at a higher state of charge, anywhere from 15% or higher. 30 is better, especially with a Rivian, but it's going to be depending on your vehicle, because not all vehicles are going to pull this many amps at once. You know, even though the Tesla Supercharger is rated for 500, you have other vehicles that's probably going to pull around 2, and it also depends on your state of charge. It may surge for a little while, but it can probably handle that surge up to around 360 amps for a short period of time. But again, you see the message right here, charging speed reduced, limited by charging station. Again, that has to do with the signals being put forth by those sensors in this cable. And again, there's 2 sensors. There's one on both ends to throttle it to make sure that it's charging within a safe range. What I'm going to do next, I'm going to pull into another spot over there. And so you can see what it's like to pull into a normal spot. Again, this is not a normal spot for charging. And so I'm going to pull into one of those stalls. So I'm going to go ahead and disconnect and move my vehicle. So I just shut the charging down, and then I'm going to go ahead and disconnect. And the proper way to disconnect, of course, is to disconnect from here first, and then disconnect from here. So same thing again. So first step, connect these 2. You hear it locks in. And so you can't, once you put it in, you can't pull this out without disconnecting this. And it's charging. And again, the good part is that this is not on the ground, so you don't have to worry about it laying in the puddle. Of course, I had to park farther over to this side, but still I'm within the lines. As you can see, if you come over here, I'm still well within the line here. I could have come over a little farther this way. But depending on the type of vehicle you have, like if you have a Lucid, and I could have pulled up farther too. So, but if you have a Lucid or an F-150 Lightning, that charge port is right here. So you would probably have to really park over that way. It would be a little more challenging for those vehicles because of the cable length. And I know the A to Z talked about having a longer cable initially, but I did hear a recent update that they're going to limit their cable to 5 feet. And again, I'm going to discuss why that may have to be also later on. But we're going to keep letting this run, and I'll see y'all back a little later. Okay, right here I'm back in service mode, and I'm just showing that the high voltage battery current is at 348, 349. And the DC EVSE maximum available current is 256. And so the cable is working as it was designed. It's limiting the current. Right now we have 56% state of charge, and it is pulling 109 kilowatts. And this is a second charging session. So right now we added 26.5 kilowatt hours to the pack. And it's showing it's cost me 16 bucks. And it says the charging session should end in 22 minutes and 13 minutes have elapsed. And this is for the second charging session. So that's something else to be aware of, is that if you're using this cable, it's going to take longer. But I guess you have to judge that against what, you know, taking up 2 spaces and not being able to charge at all. So those are your options. And this is also helpful if you're towing a vehicle, if you don't want to drop your trailer. And yes, will it charge slower? Yes, probably, depending on your vehicle. But you also have to factor in the amount of time it'll take you to drop your trailer and then hook it back up again. So this, I definitely will take it on a road trip with me, 100%. And is it the best solution? No. And the only reason I say that is because it has no proximity pilot disconnect on the NACS connection side. But we're going to continue to let this charge. Right now, I'm going to go ahead and check the heat again. But it seems to be doing well. We're at 60% state of charge right now, and I'm just going to go ahead and get out here and test this again. And right here at the connector, it's showing around 53 degrees Celsius. And right here is showing around 62 degrees Celsius. And this is air cooled. The Tesla one is liquid cooled. This is air cooled right here. And it's in the sun. The sun is beaming right on this. And so it's going to raise the ambient temperature up. And again, even right here, showing 64 degrees Celsius. And this is the outer temperature. I'm not sure what the inner temperature is, but that's still below the cutoff for this, and that, which is 75 degrees Celsius to throttle it down, which so it may be 75 degrees because Celsius because it's throttled, and then 80 degrees or 85 degrees Celsius before it just cuts off. But so far so good. It's been doing pretty well. And this is pretty hot outside. This is like worst case scenario. And I'll see you all back a little later. Okay, I'm about ready to disconnect here. As you see right here, we're at 79% state of charge. And it's pulling 54 kilowatts. And you can just see how just pretty flat charging curve. So it's basically pulling between 110 and 100 and I guess up here is like 114, but pretty flat between 114 and 110. And then it dropped down at 68% to 81 kilowatts. And then it dropped down again when it hit 74 kilowatts to 82 kilowatts. And right now we're at 80% and we're pulling 54 kilowatts. So I'm going to go ahead and shut this charging session down. All right, it's shut down, and we have added in this second session. This is the second session. We had the first session when I was just testing the cable out. This is the second session where I charged it up to 80 to see how it was going to hold up, and it did pretty darn well. We put in 55.9 kilowatt hours into the pack, and yeah, we had 243 miles. And I'm just going to hit this with my gun again. I'm going to go ahead and disconnect. When I get home, I'm going to give you my final thoughts as far as whether I recommend this for you or not. And so again, just to test the cable, and this is showing 64 degrees Celsius. And again, right here, about 62 on the high end, 62 degrees Celsius. So we'll go ahead and disconnect. So you can disconnect there first, and then you disconnect here. Oops. And there you go. And so this performed pretty well. It had a pretty flat charging curve and didn't have to take up 2 spaces. And you know, so if this charging station was full, wouldn't have been an issue. You see, I was able to charge at that one and also at this one too. But I'm going to give you my final thoughts a little later, but I'll see you all back. So I'm just going to give you my final thoughts on this and some tips. So first of all, if you're going to decide to purchase something like this, I don't recommend that you keep it in your front trunk, especially on a road trip. It gets pretty hot up here. And so, and that's going to raise the ambient temperature up in this thing, you know, before you even get started. So in this, I probably keep it inside my tunnel, my gear tunnel, or keep it inside the cabin. Same with the R1S or whatever vehicle you have. You may want to keep this in the cabin. The same thing I do with these. I don't keep this in the front trunk, and this thing is hot right now, and we haven't even used this. So I usually keep this in my driver's side door or either in the passenger door, just to make sure it's as cool as possible, because once it gets heated up, it's gonna slow the charge down. And the cost, this thing is pretty expensive. So $599 on their website. However, if you use my discount code, which I leave in the description, you get a 20% discount. And so that's good for taking about $120 off the price of this. Is it expensive? Yes. However, I paid over $200 for this by itself. Got that for free. And Rivian's CCS adapter on their website is $300 by itself. And so just kind of keep that in perspective. With this, you're getting an extension cable to go along with this. And these things are not cheap. The wiring in here is pretty expensive. And you have the sensor, so yes. And so, and then you just have to figure out whether or not your use case fits it. Me, I definitely would take it on, 100% would take this on a road trip. Again, this is an issue here. My recommendation to the company is that, you know, put a proximity pilot disconnect on this. And if you can't do that, definitely put a warning on this, some type of warning label, letting the consumer know to do not disconnect this until you cut power either through the app, because this can be pretty darn dangerous if someone disconnected this and then it created an arc, and that can be pretty catastrophic. So you have to judge for yourself whether or not this will be something that'll be good for you. Me, yes, absolutely. What about you? Would you use this?
Me? I thought you were talking to me.
Would you feel comfortable using this?
Yeah, I would. That's because I know about it now.
Okay, so, and that's, you know, part of it's knowing. So if you understand what the precautions are, and again, this thing right here, you should be good to go, just as long as you know how to use it properly. And the same goes for all of these too. Same, man, these things are hot. Ooh boy. Same goes for, again, don't store these in your front trunk, whatever you do. If you have a Rivian, if you have something else, don't store it in your front trunk either, because you probably really don't have a good one anyway. Let me know your thoughts in the comment section. You know, do you think this is dangerous? Is this something you would consider? I'm also going to be making a video where I talk about the limitations of this as far as being air cooled, and I'm going to discuss different wire sizes and what that means and the cost and things like that if a company was trying to produce one of these, and how expensive it actually could be, and you know what type of wiring they would need to get a certain amount of voltage through. But that'll be in my next video. But let me know your thoughts in this one, and if you haven't already, please like and subscribe. That's all I have for today. I'd like to thank you for joining me once again, and I can't wait to see you in the next video.